As so we're going to talk about solving some equations by graphing. So before I show you on your calculator how we're going to make life a little bit easier using that, what I want to do is talk to you about what it is we're doing. We are going to focus heavily on intercepts. So tell me what an intercept is. Crosses over an axis. So what kind of intercepts can you have? A y and an x intercept, right? Tell me. Actually, you can't have a z intercept if you're graphing on a three-dimensional xyz plane. Okay. Whew, takes me back to college. Okay. X intercept, y intercept. Tell me what happens besides it crosses the axis. In other words, what always happens at an x intercept? Not slope.
It's zero. Zero. For x, it's a number 0. For y, it's 0.
Good job, Meg. At every x intercept, y is 0, and at every y intercept, x has got to be 0. Okay. I think, Adea, what you were getting ready to say, or what you were trying to say, is where we talked about at those intercepts, the sign changes from a positive to a negative, or a negative to a positive function, right? Is that what you're trying to say? Okay. Okay. All right, so I'm going to use this to think about this algebraically for just a second, okay? If I have this equation, y equals 1/2 x squared plus 1/2 x minus 6, and I go, oh my goodness, that looks so nasty. If I asked you to find the y-intercept here, what would you do? Why? I would let x be 0, and I would say, okay, that means y equals 1/2 times 0 squared plus 1/2 times 0 minus 6, which is -6. So it should be crossing the the y-axis at -6, right? But if I asked you to find the x-intercepts, oh my, that was loud. My goodness. Okay. If I asked you to find the x-intercepts, it gets a little stickier, right? This time I'm letting y equal 0. But do you know how to solve this? Do you? Okay, well, everybody else, do you know how to solve this? This is a quadratic, and we'll talk about quadratics extensively in Chapter 3. So, no, most of us do not know how to solve this at this point, right? Okay, here's what we're going to do. When the equation equals 0, okay, when the equation equals 0, then the solutions, and notice I said solutions because it could be more than one, are the places where it crosses the x-axis. Why? Because that's what I was finding. I was finding the x-intercepts. This is also called, come on. This is also called zeros, solutions. Any of those words are synonymous with our x-intercepts, okay? So, since I'm finding x-intercepts, if I want to solve that, I can graph it, look, and find where it crosses the x-axis, okay? Here's where our calculator is going to come in. Now, sometimes I'll give you a graph, and you'll look at it, and you'll go, oh, that's the answer, okay? But for sometimes, we're going to have to, where did my calculator go down here? All right, here's what I'm going to do. I'm going to input this. I hit y equals. Have y'all graphed anything on your calculator yet?
Yeah.
Didn't we graph something in here? Okay. Yeah, we did the max and min and all, right? Okay. So go back into your y equals. Okay. Y equals. And we're going to input. Hit clear.
Oh my goodness.
All right. 1/2. What's wrong? X squared. It is a parabola. It is a parabola. Plus, y'all, I really had a brain fart. I forgot that we had done all that graphing before, so this won't be so bad. Minus 6. It's 1/2 x squared plus 1/2 x minus 6.
Because it's a square.
Because it's a squared, it is going to give us a parabola. So if I go zoom 6 to look. Now, remember, you might not see everything you need to see, so you might have to adjust your window. Okay?
So your two solutions are where they cross.
It's where it crosses. But do not just look at this and say, oh, it's -4 and 3. Because I have to actually calculate it. Your window range is wrong. Your max is not bigger than your min. Hit zoom 6. All right. Y'all stay with me because we're going to calculate the zeros, okay? Everyone's graph should look like this at this point. You typed something wrong. Do zoom 6. So now what we're going to do, because you cannot tell exactly, this is an easy problem here. And yes, this crosses at exact whole numbers, but they're not all going to do that. Okay, so I need to show you how to calculate. Second trace, same thing we did with the maxes and mins, remember? Except this time, which one do you think I'm going to choose? 0. Remember, X intercept, aka 0, aka solution, right? So choose 0. That's another name. Now, it doesn't. I'll have to help you in just a minute. All right. Left bound. Here's what you need to understand, and this is the part where we start getting confused. When you're left and right on a max or min, it's a little bit easier because you're literally left and right. Sometimes left and right on this is up and down, okay? So what you're going to do, this is what I always tell students until you fully understand. Essentially what you're doing is you're giving it a range to look in and saying, find where it crosses the x-axis between here and here. Okay? So go as close as you can get to the 0, okay, about where you think it is, and click over twice, 2 or 3 times to the left, and hit enter. See that little arrow that popped up? That is going to bound me. That's giving a boundary. Well, it's giving it a boundary. It's saying from this point, and now we're going to go the other way. Okay? Go back to the 0.
Does it matter which side you're on?
It does. It has to be to the left. You have to put your clicker close to it, and then you have to click left because it's telling you left.
Wait, what? If it says left down at the bottom,
You have to go to the left, yes. When it's telling you right bound, guys, I asked y'all to please stay with me, okay? You cannot get frustrated with this. If you have to just watch me a minute and listen, then do that, okay? Otherwise, you're going to frustrate yourself and everybody else, okay? Do you see my blinking spider is on my 0, or as close as I can get it to my 0? At the bottom, what is it telling me to do? Right bound. So click the right arrow. 1, 2, you can do it 3 times if you just want to make certain. And hit enter. Is that my 0? No. What does it say?
yeah.
Guess. Do you want it to guess what the 0 is? Well, that's the whole reason I went through all this. So hit enter one more time. What is that intercept? Negative 4, 0. One of these solutions is x equals -4. Okay? Now try it with me. Okay? I'll have to show you. It's way different. Second trace. Okay? 0. put it on the 0, or put it as close to the 0 as you can get. It does not have to be exact, okay? You are telling it, I want to find the 0 between these two numbers. Go left twice. Hit enter. Back to it. Right twice. Enter. Enter. You didn't cross over the line. You didn't go left and right. You're still in your G-solve, if I remember correctly, but you're choosing root instead of, because I should have put AKA root.
Or I put X calculate, and then it tells you to put in a Y intercept. So I put, or no, a Y value. So you put 0 in, it gives you one of the zeros, then you press the arrow key, and it gives you that.
Okay, so that might get, okay, you can do it that way, or you can, under your G-solve menu, you should see an option for root, I think it is.
Yeah, and then you just go back and forth.
Yeah.
It does the same thing.
Yeah, it does the same thing.
When you give a guess, what do you do?
Enter.
Guess. It says error.
For some things.
Error.
For other things, it's not. Which is why we promote the TI. Yeah. Yeah, let me pause this just a second. I think it will help you a little bit. When we started talking about when is the function positive, when is the function negative, right? It's positive when it's above the x-axis. It's negative when it's below the x-axis. Your calculator is looking for when it changes signs. So if it says no sign change, then you were both negative or both positive. It's looking for when the function, because that's the 0, is when it changes from positive to negative or negative to positive. So you have to give it one negative and you have to give it one positive for it to find where it changes, the point at which it changes, okay? Let's do one more. That was an easy one.
I like this a lot better than you guys.
All right. Find the root of the linear equation. What does root mean?
Zeros.
Which zeros? The zeros are the same thing as what? You're right, it's zeros. Yes, the X intercepts. All right, so find the roots of that. So what are you going to do?
Y intercept is
And I'm going to say find it by graphing.
Wait, could you show the...
Yeah, I'm sorry. Find the roots by graphing.
Wait, what does root mean again?
Root means X-intercept. Root, 0, solution, X-intercept, those are all synonyms. R-O-O-T-S, yep.
How do we write the equal to?
So you don't do that. That's where your root comes in, okay? So negative 2x plus 10 and graph. Literally putting it in your calculator. I'm going to have you sketch the graph to make sure you're putting it in your calculator correctly. And then I'm going to second calculate my 0. Oh, second trace, I'm sorry. I'm coming right about there, left bound, click left 2 or 3 clicks. Notice I'm on the positive part of the function, right? Hit enter. Now I need to make sure I'm on the negative part of the function for my right bound. I'm clearly in negative territory, right? I've crossed over to the other side. Hello from me. Okay. Now, do you want me to guess? Yes, obviously I do. What is the solution? 5. Now, this is an easy one. It's a linear one. If you solved that for x, would you get 5?
Yes.
Yes, that's an algebraic solve. If I subtracted 10 from both sides, and then I divided by -2, I get 5. This is an algebraic. What we did here was graphically. Okay. 2 different ways of doing the same thing. Okay?
Yeah.
I can say that about my
All right, one more. Because here's where we apply it. Y'all ready? Last one. Listen. Tell y'all like my son's coach told him last night, you have 2 ears and 1 mouth for a reason. Listen. Listen. Sarah stopped at a bakery to pick up 1.5 dozen cupcakes for a class party. She should have. If she was smart, she would have. She was charged $7.88. Which included 38 cents in tax. That's already added in there. Okay? How much does 1 dozen cupcakes cost?
So it's exact accurate.
Okay, say it again, Lizzie. Say it again. So I'm going to make it 3/2. X does that make sense? But you would subtract, right, if we're solving graphically. Now this would be an easy solve if we were solving algebraically, right? And I promise you there's a reason that I'm making you go through all this graphically stuff, because we're going to get to some really, really, really nasty equations that you're going to want to be able to solve graphically, because algebraically they're going to be near impossible. So if I were to solve this graphically, I need to make sure it equals what before I start? 0. Right? My equation needs to equal 0 whenever I plug it in. So you got 3/2x minus 788 equals 0. Now graph that and tell me what the cost of 1 dozen cupcakes would be. Is it 5 even?
You don't do anything with the 38 cents.
Yeah, why is there good?
It said, okay, so it says that she was charged $7.88, which included 38 cents for tax. So to me, that's already in there. That's some extra information that. Now, if you want to know the price before tax, but they didn't say that. You see what I'm saying? They asked me, what's the price per dozen? If they said, what's the price per dozen before tax?
Because that you cut into.
It's a whole different problem.
That taxes include things.
Right, right. So how much is a dozen? Did you get it? Is that right?